friends, I welcome you all to the course of Marketing Research and Analysis second part. So, in this course we have been discussing about several things used in the field of marketing research, and in the last few classes we have been discussing about basically experimental research, experimental design, and then followed with we started with analysis of variance one way and two way, right. And today we will be continuing with the same thing, multiple analysis of variance and analysis of covariance in the coming lectures. So, let us begin with the same which we had stopped in the last lecture, that was N way ANOVA. So, as you understand, N way stands for that means when there is more than one factor, right. In the case of analysis of variance study, so there is more than one factor, then we say it is N way, right. It could be 2, 3, 4, 5, anything. So, N way, so that is why N factors N way ANOVA, right. So, what happens in this N way ANOVA is, what is the advantage? The advantage is that many a times in life you need to understand that there could be more than one factor which is affecting the the dependent variable. So, the dependent variable is maybe is a continuous metric variable in our case, in case of ANOVA, and the independent variable is measured in a categorical scale, right, categorical way. So, let us say I want to understand, for example, the influence of the kind of school, right, the type of school on the students' marks, the grades of students. Now, what I am doing is, or the type of teaching method or the type of school, whatever it is. So, when I am saying the independent variable, that means is which affects the dependent variable score is my type of school or type of teaching method. So, in there I have 1, 2, 3 let us say I have school A, which is a public sector school, public school, a private school, right, some cooperative some schools run by cooperative as 3. So, I have several schools, right. Same time the researcher feels that not only this type of school, but the type of teaching method adopted by these schools, maybe are they technology based, are they blackboard chalk and blackboard based, how they are teaching. So, this also has an effect. So, when he takes two such factors at the same time, school and the type of teaching method, there a one way ANOVA does not work, right, and if he does more than several one way ANOVAs, then again it is a not a very advisable thing, because it leads to higher type 1 errors, right. So, how to do this we will see, we have done in the last class through a very general primary method. So, today I will show you one more problem on the N way ANOVA. So, as it says, the major advantage is that it enables researcher to examine interaction between the factors. This is the biggest advantage of the N way ANOVA. So, in one way ANOVA you had no chance of understanding the interaction effect. So, in N way ANOVA you have two factors A and B. Now, whether A and B, is there a third factor which is A and B combined together. So, this effect is the most important thing, that in real life it has a very huge profound impact. So, that means variables do not individually affect the dependent variable, but they affect the dependent variable in a combined manner. Okay. So, the procedure for conducting N way ANOVA is similar to the one way ANOVA, it is similar, right. So, only thing is it adopts a general linear model method, which I will show you what it is also I will tell you. So, in a two way ANOVA you will have 3 F ratios, in a two way ANOVA you will have 3 F ratios. What are these 3 F ratios? The first one, it says the first independent variable has a significant main effect on the dependent variable, right. So, one of this will tell you if your first independent variable, that means the first factor has a significant effect, main effect on the dependent variable or not. So, this is the first F. Second F will be the second independent variable or the second factor has a significant main effect on the dependent variable or not, right. The third will tell us the interaction of the two independent variables, the factor 1, the factor 2 together, taken together. So, that is if the impact of one independent variable depends on the level of the other or not. So, this is what is the interaction effect. So, these 3 F ratios are determined during the N way ANOVA, right. So, let us take this example. In the last class we had done one, so today we will do one more, right. In this what is happening, let us see. CEOs must decide whether to award a dividend to stockholders or to make a company investment. they want to pay to the dividend to the stockholders, or they want to put back the money as a form of investment into the company. To determine this, researchers randomly select 24 CEOs and ask them to rate how important availability of profitable investment opportunities is in deciding whether to pay a dividends or invest. Okay. The CEOs are requested to respond in a scale of 0 to 4, where 0 is no importance, that means there is no availability of profitable investment opportunity, 1 is slightly important and it goes on, where 4 is the maximum important, right. So, this is the the 0 to 4 response is the dependent variable in the experimental design. So, so this is what is basically is the thing that we are trying to see, ki how important are they really feeling important or not. So, what they are doing here is the business researchers are concerned that where the company's stock is traded might where it is traded, that means is it traded in the New York Stock Exchange or American Stock Exchange or some over the counter, right. Whether the place where it is traded, does that have an effect on the opinion, will it make a difference in the CEO's response to the question, or in addition the business researcher believes that how the stockholders are informed of the dividends, they might also affect the outcome of the experiment. So, now what is happening, there are two things that might affect the outcome of the CEOs. One, where the company is trading the stock. Second, how they are informing the stockholders about the dividends, how, right. So, what are the methods? So, how stockholders are informed has two levels, these two, through quarterly reports, through presentations. Where they are traded, the three levels, 1, 2, 3. Okay. So, this is a factorial design with 2 cross 3 ANOVA. Why we are saying it is a factorial design? Because a factorial design can take up any number of levels, right, any number of factors, unbalanced also, no issues, and it allows for a interaction study, right, with 4 measurements per cell. Okay, 4 measurements per cell. So, because there are, if you see 24, right, 24 CEOs and there are 6 total factors, right. So, each cell 6 cells, so each cell will have 4, right. Now, hypothesis, what is my hypothesis? The combined effect of how stakeholders are informed and where the stocks are traded have no significant effect, okay, on the CEO's decision to pay dividend or invest. Second, how stakeholders, so this is my interaction effect, okay, correct. Second, how stakeholders are informed of dividends have no significant effects. So, what is this? The significant, this is the main effect of, the first factor, which is the way the information about the dividends is told to the stockholders, right. Second, the third, the exchange where the stocks are traded also have no significance. So, this is again the main effect for the stocks trading, the trading of the stocks. So, this is main effect B, this was main effect A. Okay. So, in this problem you see we are having how the information is given to the stockholders. So, through the reports and the through the presentation, right, and how it is, where it is traded, stock exchange, New York Stock Exchange, American and over the counter. Now, first let us find out individually for, there are each 6 cells 1, 2, 3, 4, 5, 6, for each cell what is the mean, right. So, for the first cell, right, and this first cell it is 1.5, 3, 4, 5, 6 divided by 4. Similarly, for the second cell it is 2.5, third cell 3.5, fourth, fifth and sixth. So, individually for each cell first you find out the means, right. Then for annual quarterly report, what is the average mean? The average mean is, if you take 3, how many are there? 1, 2, 3. So, 3 2.5 plus 1.5 4 plus 3.5 7.5 divided by 3 is 2.5. Similarly, for the presentation it is 2.9167. For New York Stock Exchange, if you go vertically, then what is the mean? 1.75. For American Stock Exchange, what is the overall mean? 2.75. For over the counter, what is the overall mean? 3.625. My grand mean is the summation of this plus this divided by 3, or this plus this divided by 2. Okay. This comes 2.7083. We have taken a significance level of 5%. Okay. Now, let us solve this problem. So, first we need to find out 5 things. What are they? Sum of square for the first factor, sum of square for the second factor, sum of square of the interaction between the first and the second, then sum of square within or which you say also error, right, within, then sum of square total, right. If you find any 4 of it also, then the fifth one is automatically we can find out, right. So, let us see the first one, sum of square for the first factor. So, the first factor, right. So, how many first factor is, let us say we are talking about this one, right. So, we are talking about this one. So, how many cells are there here? 3, right. So, n 4, which is each cell has got 4 members, 1 2 3 4, right, 1 2 3 4, right, into 3 cells into 2.5 minus 2.5 minus 2.7083 square plus 2.91 minus 2.7. So, this gives us 1.0418. Let us find out for the second factor. So, what is the n? Again 4. How many cells are there this time? Now, how many cells? Now, for example, we are trying to see the cells for each, right, 1 2 1 2 1 2, right. So, 2 cells. So, 2 cells. So, 1.75, let us go. So, 1.75 minus 2.7083 square plus 2.75 minus 2.7083 square plus 3.625 minus 2.7083 square. Now, if you do this, you get a score of 14.0833. Now, we are finding the third. This is done, this is done, the interaction. So, what is the interaction? Interaction is saying 4 then into, how do you find out, xij, right. So, let us see. So, this value xij is x11 or x12, this value, right, minus the corresponding mean, right. So, this minus this square plus this minus this square plus this minus this square plus goes on. So, 1.5 minus 2.5 minus, you see, xij minus xi first one, then xj. So, I and j. So, I first row and j is my column. So, column wise if you go is 1.75. So, 1.5 minus 2.5 minus 1.75 plus 2.7083. So, this square plus similarly 2.5. Now, go to the next one, 2.5 minus, it goes 2.5 minus 2.5. So, 0 minus 2.75 minus 2.7083, right. So, it gives us 2 square plus similarly 3.5 minus 2.5 plus 3.5 minus 2.5 minus 3.625 minus 2.7, right. So, as you do this, so this is the formula for this, if you can remember it also. So, xij mean of the first cell minus the total of that column, right, that row, similarly minus the xij plus the grand mean. So, if you use this formula, we are getting a 0.0833, right. Now, once you have got this, then you have to calculate the sum of square within or this. Now, how do you calculate the within? Within means each cell minus that particular mean, right. So, 2 observed value is 2 minus how much, 1.5 square plus 1 minus 1.5, it goes on. So, plus goes on till you reach to 3 minus let us say you see up to this. So, individually, so this minus this minus this plus this minus this minus this minus this minus this goes on for all, right, till you reach 4 minus 3.75 square. So, this total overall total, right, is equal to 7.75. Now, sorry, sum of square error, sorry, within, and what is my total? Now, if I add this 4, right, interaction within, if I add this 4, I will get total, or else simply you can do one thing. If you get confused with, let us say, interaction or any one of it, first one is very simple, second one is very simple, you may not remember the formula, just find out the total. How to find the total? Every cell minus the grand mean. Now, here 2 minus 2.7083 square plus 1 minus this this minus this minus this, then this minus this goes on for all, right. When you do this square, it gives you the total, right. So, this is equal to 22.95. So, suppose I have my total is equal to, I know that is SS of first factor plus SS of second factor plus SS of interaction, right, interaction of 1 into 2 plus SS of within, right. So, suppose I have total, I have this and this, I need not calculate this, I can also find out from here just by subtracting, right. So, anyway, so from here what we do next is we find the mean sum of square, mean sum of square. So, mean sum of square is the first, for the first factor is first one, sum of square for the first divided by the number of row minus 1. So, that is how much. So, you had for the first one there were 2. So, 2 minus 1. So, that is equal to 1.04. For the second factor you have how many? 3. So, 3 are American Stock Exchange, the New York Stock Exchange and so over the counter. So, if you divide it, then it comes to 7.04. The interaction is sum of square of interaction which you have calculated divided by r minus 1 into c minus 1. So, 0.41. Sum of square, the mean sum of square error or within is equal to, this is the formula, sum of square of errors into row into column into divided into n minus 1. So, this is giving me 4.3. So, I am getting the first factor, the F ratio for the first factor, F ratio for the second factor and F ratio for my interaction. So, these 3 once I get, then I can write it like this, right. So, I see from here, so the my F values, it tells me that if my F value is you see 2.42 and this is for column is 16.35, interaction is only 0.10. Now, how do you measure it, how do you write it? So, the overall effect F at 518, 5 and 18 is the numerator, the degree of freedom for the numerator and denominator at 5% level of significance. The critical value from the F table is this much. For this row and column, if you find out, the table value is this much, the calculated value is this much. So, since calculated value is greater than the table value, we reject the null hypothesis. Now, you see we have calculated here. So, F is equal to how much? 1.04 plus 14 plus 0.08, right, divided by 5 then this is my upper side and then within, this is my within, right. So, within is how much? Now, 7.75, right, divided by 18, right, degree of freedom is 18. So, overall I am getting a F ratio of 7.05. My degree of freedom is, this formula is also given to you, you can check it, right. So, from here we can infer what is our interpretation. Since the overall model was significant, we move next to check the significance of the interaction effect. The critical value for the interaction effect is 3.55. Okay. The observed value, observed F value for interaction effect is this much. So, this is my table value, this is my observed. So, since the table value is much more than the calculated value, this value is less than the table value. So, no significant effects are evident. So, the interaction effect is not there, and remember, when there is no interaction effect, the researcher should move next to the main effects, right. And because no significant interaction effects are present, it is possible to examine the main effects. Now, what is the main effects? The critical F value of the row effects at F significance is 5%, 1 and 18 is equal to 4.41 and the observed value is 2.42. Hence, again no significant row effects are present, that means the main effect of first factor is also not present. Similarly, that means we can say the stakeholders are informed of dividend, which way they are informed of dividend has no significant effect, right. Similarly, if you take the second effect, the column which was the counter, which over the counter or the which kind of stock exchange. So, F is equal to this much is 3.55 and the calculated value, the observed value is 16.35, which is much higher, right. So, when it is much higher, we reject. So, we say the stock exchange, the type of stock exchange where the researcher where the the stock is being traded, that plays a significant effect on the CEO's decision whether to invest or not to, or to pay dividends, right. So, this is how you do. Now, I will show you how to do a this is not a one way, this is sorry, this is a two way, right, this is not two way. So, let me show you how to do a two-way again. So, let us take this. So, this is a case where there are types of cars, there are different types of cars. So, you can see, so there are cars, the type of filters and their effect on the performance. Okay. So, I want to check whether the performance of my performance means fuel performance is affected by the brand of the car and the kind of filter that is being used within the car, right. So, let us see how to go when you have two factors. So, that means you have factor 1 and factor 2. So, when you have two factors and there is one continuous dependent variable, this is a case for two-way ANOVA, right. So, let us do this. Now, how to do? Now, we go to the first general linear model and univariate. Why univariate? Because you have only one dependent variable. So, performance I am taking as my dependent variable and car and filter as my independent variable. Now, what I am doing is I will go to see whether I have the what is the main effects and what are the interaction effects. To see that, first I will take this and I will take a car into filter. So, this is a interaction effect. Okay. Then what is this post hoc and do we require post hoc? Yes, we do require, but you require only post hoc when there are more than two levels. So, then only it is a comparison of the means, right. So, only car is possible because car I think there are 3 brands. Okay. And the most effective method is the Tukey's method, which we will use, right. So, there are 3 methods, in fact the CDAC method is also used and Bonferin is also used when there are small cases of samples, but we will use the Tukey's method, right. What are the options? So, I need to see the means for all, right. So, all the 3, right, and I want to compare the main effects in case my interaction effect is not working, is not significant, then I will use that. So, these 3 things I require and I continue and I go to OK. Now, let us see whether what kind of analysis we are getting. Now, look at this, we are having 3 cars, 2 filters. Okay. Now, the first car and the first filter, this is 1, 2, 3. So, the first car fitted with the first type of filter, mean is 15, second is 18.5 and this value you can see for the third car with the first filter is 15 and the second one is 12. Now, first of all we want to see that the assumption of homogeneity of variance. Now, homogeneity of variance, this is a very important test because it says and you need to report it when you write your research paper, whether there is a homogeneity of variance, that means whether the groups do have a very equal variance or not. So, that is our null hypothesis. So, here the Levens test says or the homogeneity of variance test says that yes, it is significant at 0.246, that means the null hypothesis cannot be rejected, right. So, what is the null hypothesis? That there is an equal variance among the groups. So, it is correct. So, that means there is a homogeneity of variance. Next, now let us look at the test of between subject effects. Now, if you look at car, right. So, is it first of all let us look at the F ratio 5.4 and the significance. Is it significant? Yes. The kind of cars affects the performance. Filter, well, no, 0.745. So, it is not significant, right. Is the interaction effect playing an important role? Yes. The interaction effect of car and filter has an important role plays an important role and it is significant. So, when you report, when you write, you have to write, and what is this partial eta square? It tells you the effect size. So, for example, you see the effect size is 0.142 for the car and 0.145 for the car, the interaction effect. So, now if you can see the pairwise comparison, that is a post hoc test effect. So, we want to compare one car versus 1 and car versus 2. Is it a significant difference? No. Car versus 1 and car versus 3, is there a significant difference? Yes. Car versus 2 and 3, is there a significant difference? Well, no. 3 and 1, yes. So, the study helps us to find out which independent variables affect the dependent variable in how and what is the effect of the when you compare the groups, how the groups are affecting finally the dependent variable. So, this is what we are doing in a two-way ANOVA, right. So, you can see this for also for filter and all, but we are not interested, right. So, car into filter. So, the post hoc test you can see this. So, it is given to you, right, these values are important. Okay. So, now I will close it, no. So, I close this also. Now, I will go back to my slide. So, now in fact I wanted to start with this multivariate analysis of variance. I will just begin with what is this multivariate analysis of variance. To continue, multivariate analysis of variance is a technique which is a step over the ANOVA, and it allows you for, in the ANOVA case what happened, we had one dependent variable continuous, right, with several independent variables, let us say IV1, IV2 which were categorical, correct, this was the case. Now, what if the case is different? Now, we have multiple dependent variables, let us say you have one dependent variable, then you have two second dependent variable, and you have two independent variables, or you can have whatever condition, right. So, when I have more than one independent dependent variable, so this study is a case of a multivariate analysis of variance. So, multivariate analysis of variance, we will just see, is used to determine whether there are any differences between independent groups on more than one continuous dependent variable. In this regard, it differs from an ANOVA, which only measures one continuous dependent variable. So, that is the difference, right. Now, types of ANOVA, you can have one way or again n way. One way ANOVA, if the independent variable is only one, you have only one independent variable, and dependent variable is more than one, is a case of a one way ANOVA, right. In the ANOVA, what was happening? You had one factor, then one way ANOVA. If you had more than one factor, two factors, we are saying two way ANOVA, and three way. You can use ANOVA to understand whether there were differences in the perception of attractiveness and intelligence of people who are vegetarians, right. That is, two independent variables, perception of attractiveness and perception of intelligence, was measured taking independent variable as whether the person is vegetarian purely or purely non-vegetarian or a combination of both, right. So, when I have such a kind of study, so what I am saying, my attractiveness is measured as a continuous variable, intelligence is measured as a continuous variable, but the food, the independent variable which is affecting this, is consumed as measured as categorical 1, maybe 2, maybe 3. So, when I have this case, it is a one way. Similarly, if the independent variable are 2, there are 2 independent variables now, and dependent variable is also more than one, it is a two way ANOVA case. Example, you can use ANOVA to understand whether there were differences in students short term and long term recall of facts, right, short term and long term recall of facts based on 3 different lengths of lecture. So, there are 3 different types of lecture. So, the 2 dependent variables are short term memory recall and long term memory recall, right. What are my independent variables? Lecture duration. So, which has 3 categories, 30 minutes, 60 minutes and 90 minutes, and the teacher's educational background, which also has 3 categories, arts, commerce and science. Now, you see you have 2 independent variables which are categorical in nature, one the duration, so these 3, and now and the teacher's background, arts, commerce and science, and what is my dependent variable? Now, there are again 2, short term memory and long term memory recall. So, when I have this case, right, how do you solve this problem? So, to solve this problem, we use the multivariate analysis of multivariate analysis of variance, right. So, these are some of the assumptions we will see. Your 2 or more independent variables should be measured at the interval or ratio level. What is it saying? Your dependent variables should be measured at interval or ratio level, that is they are continuous. Examples of variables that meet this criterion include revision time, intelligence, exam performance, weight, etc. Your independent variables should consist of 2 or more categorical independent groups. What are example? Now, for example, the north zones in India, for example, from which zone does the person come? North zone, west zone, south zone, east zone, right. What physical activity does he have, right. So, there are 4 groups, for example, sedentary, low, moderate and high. What is his profession? surgeon, doctor, nurse, dentist and therapist. So, when I have this kind of a condition, so you see my independent variables are categorical, dependent variables are in a ratio or real. So, you should have independence of observations, which means that there is no relationship between the observations in each group or between the group themselves. That means, they are all individually different. There must be different participants in each group with no participant being in more than one group, right. And you should have an adequate sample size. So, the larger your sample size, the better. You need to have more cases in each group than the number of dependent variables you are analyzing. The basic rule is 20 observations for each level. So, suppose you have a one factor with 3 levels, what should be your sample size? The 20 into 3 is equal to 60. Suppose you have 2 factors with 2 levels, right, each. So, how many? Now, 2 into 2 into 20. So, how much is it becoming? For 22 to the 40 to the 80. So, it goes on. So, you can find out. So, well, I will just stop here, right. I will wind up here. We will continue in the next lecture. Today we discussed, again we solved one more problem with analysis of variance or two-way analysis of variance, and we have just started with MANOVA. In the next lecture we will continue with MANOVA, and I will try to cover ANCOVA also, analysis of covariance, which is another technique where a covariate is used, and then we will proceed further. Thank you so much.